Okay, so we calculated a bunch of numbers, right? We did choosing for card hands. Let's see if we can come up with the probabilities of these things. So, first things first, I need to know how many possible card hands there are at all, right? So that's this kind of, how many hands are there thing?
2,598,960.
Say that in scientific notation.
The whole thing?
Just say it again.
Oh, 2,598,960.
Okay, so 2.6 times 10 to the 6th card hands, roughly.
Round up the bottom.
Okay, so how many ways are there to get, say, a dead man's hand? What did we pick there? We did 4, choose 3. That's what?
4.
4. Why is 4, choose 3, 4?
Picking the one you exclude.
Yeah, you're picking the one that you're leaving in the deck, right? So there's 4 ways for me to pick 3 of the aces out. And then what's 4 choose 2? 6. Okay, so there are 24 possible ways to get a dead man's hand, right? Out of 2.6 million possible hands. So what's the probability of drawing this silly thing?
4 out of 2.
9 to the negative 6.
9 times 10 to the negative 6?
Yep, about. So a million?
Yeah, so 1 in a million, give or take. Does that seem about right?
Yes.
It's 1,000th percentage.
Yeah, this is not very high. Maybe an extra 0?
No. That's proportion.
Never mind, I'm good, sorry. I just lost a 0 in my head.
You just LeBron. They just threw it.
Hey, okay. I have no idea what that means.
They just threw my pencil in the trash.
Okay, cool, good talk. All right, so odds of dead man's hands are extremely small. How about the odds of a full house? Or the probability of a full house? I keep saying odds. Odds and probability are slightly different. We're learning to calculate probability, which is the number of occurrences of the thing I'm interested in divided by what? The total number of occurrences of any darn thing, right? Okay, so how about this full house business? What do you get out of this? How many different ways are there to come up with a full house? 13 times 4 times 12 times 6 is, seems like a big number, right?
3,700. 3,744.
Okay, 3,700. But what's the probability of that?
Still kind of small compared to.
Compared to what? That's actually a good question. So what did you get when you divide this thing? So this is probability of a full house.
0.0014.
1 in 100 hands.
1 in 1,000 hands. You guys see that? So 1 in 1,000, 1 in a million.
Much better, but still not incredibly likely.
Yeah, this is a lot more common, right? Why is any full house at all more common than that one?
There's a specific group of full houses.
Yeah, because
More constraints.
a full house versus really it's that one, right?
1 of 24.
I specified a bunch more stuff to get to that, so it's of course much less likely. You guys see that? So how high can these numbers go? That's actually a good question. Probability, right? The best it could go is, like the biggest number I could get out of this thing?
You choose
What?
a hand. What's the probability you choose a
Yeah, what's the probability that given that you get a hand that you're going to get a hand. Right? Why? You guys see that? So when you're comparing these, right, don't think to yourself, oh, that's a tiny little number. Right? Things that are 1 or 2%, they happen a lot. This happens actually a fair bit, right?
How did you get the 0.004? You divided.
I took this number, 3744, and I divided by that number, 2.6 million. Cool? How about this one? You guys want to go through that one? Spend a second on your own and get a number for that.